Welcome to Ask and Learn.
Okay, so the radius of convergence is going to be limit as n goes to infinity of absolute value of an over an plus 1, where an is this chunk here without the x value. And yeah, maybe we'll do it using the ratio test, just in case this is confusing to anyone. So the ratio test, we do the same type of thing, except we have the subscript with the n plus 1 up top now, and by this bn, now we do mean this whole chunk here, including the x values. So this is going to be x to the n plus 1 over 1 times 3 times ... times 2 n minus 1 times 2 n plus 1 minus 1. Okay, and then, so that's just our bn plus 1, and we're dividing by bn, so multiplying by the reciprocal. So now we'll have an x to the n over there. And up top, we're going to have 1 times 3 times ... times 2n minus 1. And this whole chunk here is going to cancel out with this whole chunk here. And x to the n plus 1 divided by x to the n is just going to leave us with x. So now we have limit as n goes to infinity of absolute value of x. And nothing got rid of this 2 times n plus 1 minus 1. So we still have that there. And if we're using the ratio test to figure out where we get convergence, we want for this to be something less than 1. But notice that this term is going to go to 0 as n goes to infinity. So it doesn't matter what value we plug in for x. We're always going to end up getting 0 here. 0 is certainly less than 1. So x is allowed to be anything. So the radius of convergence is infinity, which is exactly what we would have gotten if we just did this here, this little shortcut. We would have gotten that r is equal to limit as n goes to infinity of 2 times n plus 1 minus 1, and that would be infinity. Okay, so if the radius of convergence is infinite, then the interval of convergence is certainly going to be infinite as well.